Ever wondered how your favorite apps are built from design to code? Well, you're in for a treat. This mystery that we're about to unravel is an intricate process, a dance of creativity and logic. It's the journey from the abstract to the concrete, from the realm of design to the world of code. It all starts with understanding design artifacts, those precious blueprints that guide the building process. Developers then translate the concepts from these artifacts into code, creating the foundational structures that power your apps. They apply design patterns, ensuring the code is efficient and scalable. Then comes modularity and reusability, organizing the code into neat, reusable components. The magic continues as they implement the user interface, bringing designs to life. After rigorous testing and validation, they refine the code iteratively, making it better with each cycle. Finally, they document everything, ensuring the code is well understood and ready for future enhancements. So, are you ready to uncover the process that turns beautiful designs into functional code? The first step in the journey from design to code involves understanding design artifacts. Now, what are these design artifacts? Think of them as the blueprints for software development. They include elements like architectural diagrams, UML diagrams, wireframes, and mockups. Each one of these plays a crucial role in guiding developers. Architectural diagrams, for instance, provide an overview of the system's structure, highlighting its components, modules, interfaces, and interactions. UML diagrams, on the other hand, offer a more detailed view, representing the system's classes, objects, and their relationships. Wireframes and mockups, while different, are both geared towards visualizing the user interface. Wireframes sketch out the layout and placement of elements on a page, while mockups offer a more refined, static representation of the interface. Understanding these artifacts is like learning a new language. Once developers have deciphered this language, they have a clear understanding of the system's architecture and can start translating concepts into code. Once developers have a clear understanding of these artifacts, they can start translating concepts into code. With a good grasp of the design artifacts, developers begin the exciting task of translating those concepts into code. This is where the rubber meets the road in software development. The abstract ideas and structures from the design phase are turned into tangible lines of code that breathe life into the application. Developers transform the conceptual design elements into code constructs. These can be classes, functions, methods, variables, and data structures, depending on the requirements and the programming language in use. This process involves implementing the logic, behavior, and functionality as specified in the design. The focus is to ensure that the code aligns perfectly with the design specifications and requirements. It's like piecing together a complex puzzle, where each piece of code is an integral part of the bigger picture. Now, with the concepts translated into code, developers can start applying design patterns. Design patterns are essential tools for developers, helping them solve common design challenges. They are like blueprints, providing a standard solution to recurring design problems in software architecture. Let's take a look at some of the most commonly used design patterns. The Model View Controller, or MVC, separates data access, user interface, and business logic into three distinct components. This division allows for more efficient code management and modification. The factory pattern is a creational design pattern providing an interface for creating objects, enabling the instantiation process to be decoupled from the main application. Singleton ensures that a class has only one instance, providing a global point of access to it. Observer promotes a loose coupling between objects where a change in one object automatically updates the others. Finally, dependency injection allows for better testing and maintainability by reducing hard-coded dependencies among classes. With design patterns in place, it's time to focus on modularity and reusability. Modularity and reusability are key principles that guide the organization of code. They are the building blocks that allow developers to create complex software systems. Now let's imagine our code as a city. In this city, each building represents a module. Just as each building has a specific purpose, each module encapsulates a specific functionality. This encapsulation increases the readability and maintainability of the code, just like how a well-organized city is easy to navigate. What's more, just like how buildings can be reused for different purposes over time, modules can be reused across different parts of the code, or even in different projects. This reusability saves time and effort, reducing the need to reinvent the wheel for common tasks. But just like in a city, it's not enough to have great buildings. They need to be well connected, yet independent. In code, this translates into high cohesion within modules and loose coupling between them, allowing for changes in one module without affecting others. Having a modular and reusable code base sets the stage for the next step: implementing user interfaces. A significant part of the design-to-code mapping process involves implementing user interfaces. As we delve deeper into this process, we encounter a realm where artistry meets technology, the world of user interfaces. You see, the user interface or UI is the gateway through which users interact with the software. It's not just about making things look pretty, but crafting an experience that is intuitive, engaging, and user-friendly. Front-end developers are the maestros who orchestrate this experience. Their tools, HTML, CSS, and JavaScript. They weave these languages together, bringing to life the UI components, layouts, styles, and interactive behaviors specified in the design. The first step is to create the UI components. These are the building blocks of the interface, elements like buttons, forms, and menus. Each component is crafted with meticulous attention to detail, ensuring they not only look good, but also function as intended. Next, they arrange these components into layouts. Think of it as arranging furniture in a room. The layout dictates how the components are positioned and interact with each other, creating a seamless flow that guides the user through the software. Styles come next. This involves adding colors, fonts, and animations, setting the visual tone of the software. It's the equivalent of painting the walls and adding decor to your room. The right styles can enhance usability, evoke emotions, and reinforce the brand identity. Finally, they implement interactive behaviors. This is where the magic happens, where static elements come alive. With JavaScript, they can make a button respond to a click, a form validate inputs, or a menu slide out from the side. These interactions make the software feel responsive and dynamic, enhancing the user experience. So you see, implementing user interfaces is not just about coding, it's about creating an experience, a journey for the user. It's a dance between form and function, aesthetics and usability, design and code. With the user interfaces in place, it's time to test and validate the code. Testing and validation are crucial to ensuring that the implemented code functions as expected. It's akin to a final quality check before the software goes live. Developers use unit tests, which verify individual components of code, and integration tests, which ensure different code components work harmoniously together. These tests are designed to catch any unexpected behavior or inconsistencies that might have slipped through the cracks during the coding phase. It's like making sure all the pieces of a puzzle fit together seamlessly. In addition, developers ensure that the code aligns with the design specifications. They're on the lookout for any discrepancies or deviations, making sure the code doesn't just work, but also faithfully represents the original design. This meticulous process guarantees that the final product not only performs its function, but also lives up to the vision articulated during the design phase. Testing and validation complete, it's time for the iterative development and refinement process. The mapping from design to code isn't a one-time process. It's iterative, involving continuous refinement based on feedback and evolving requirements. So how does this iterative process work? Well, it's like creating a sculpture. You start with a rough shape, then gradually refine it, chipping away at the excess, smoothing the edges, and finally adding the fine details. In the world of software development, this refinement starts with the initial implementation, translated from the design. As the code is tested and feedback is gathered, developers will often discover areas for improvement, or perhaps even new requirements that have emerged. These discoveries lead to refining the code, which can involve anything from small tweaks to significant overhauls. Developers might need to address design changes, updates, or enhancements that have arisen. It's a dynamic process, constantly adapting to ensure the end product aligns with the evolving needs of users and stakeholders. Finally, with the code refined and ready, it's time to document it for future use. Documentation is the final step in the design-to-code mapping process. This phase is integral to the success of any software development project. In essence, it's about creating a comprehensive guidebook for your code. It's like a map that navigates future developers through the code base, helping them understand the system's functionality, usage, and dependencies. Inline comments are the bread and butter of code documentation. They provide immediate context and explanation for what a specific line or block of code does. README files, on the other hand, serve as the overview of your software, describing what it does, how to install and use it, and any other pertinent details. But the documentation doesn't stop there. Developers also create detailed developer documentation with insights into the software's architecture, design decisions, and code structure. This type of documentation is essential for onboarding new developers and maintaining the software in the long run. And there you have it, the process that takes a design from blueprint to a fully functioning application. Until next time, keep coding.